Hi everyone, my name is Ryan Barton, and today I am going to be doing my presentation on the selective pressures that led theropods to evolve into birds. So to start off my presentation, I wanted just to kind of ask the question to all the class, what do you think of when you think of a Tyrannosaurus rex? There's one particular image that kind of comes to my mind that I just wanted to share with all of you really quick, if I can get this to work. Okay, here we go.
Maybe it's the power trying to come back on.
What is that? Where's the goat?
So I personally think that does a pretty good job describing kind of who the Tyrannosaurus rex was. And I apologize if any of you were offended by the goat leg. But anyways, it was kind of these thoughts that led me to developing my thesis, which is what caused dominant theropods to evolve into harmless birds. And theropods, if we go on here, are bipedal carnivores. So basically, there were many different types of bipedal carnivores, as you can see from the phylogeny at the right. This particular phylogeny was made by Christoph Hendricks, and he used different type of teeth to basically group these theropods together. So this study actually kind of reminded me of the Darwin experiment with the finches with different beak sizes. So we knew with the finches, different beak sizes meant that there were different food sources that were able to be obtained from having those different beak sizes. So I would speculate that different teeth size would mean a similar thing here with theropods. So if there were many different types of teeth amongst theropods, we can also come to the conclusion that there was a great deal of competition amongst theropods. So one of the theropods that is quite famous is the Archaeopteryx. Over here on the left, you can see the first fossil that was discovered of this Archaeopteryx. It was discovered by Hermann von Meyer in 1860. Now this creature right here is pretty noteworthy just in the sense that it is said to be the intermediate species between birds and theropods. As you can see from the picture on the right, this theropod had certain avian qualities or bird-like qualities, such as an increased amount of feathers and teeth and things like that. But it also still looked like a theropod. When the mass extinction happened, I'm sure many of you are familiar with it, many different meteorites started to fall from the sky. And this killed many of the theropods that were on the Earth. Considering the size of the Tyrannosaurus rex was quite large, it is quite definite that the Tyrannosaurus rex went extinct after this mass extinction. However, according to Helena Curtis, any species that was really 55 pounds or smaller would have survived this mass extinction. So there were some theropods that survived this mass extinction. They just weren't as large and dominant as the Tyrannosaurus rex. One of them was most likely the Archaeopteryx, which I just showed. the Archaeopteryx was said to be somewhere around the size of a raven. So after the mass extinction, this led to the rise of the mammal. Basically, another way to say this is adaptive radiation took place among the mammals. And adaptive radiation, for those of you who don't remember, just basically means a accelerated evolution. So this led to some new predators coming up among the mammal family. I provided a picture here of a saber-toothed tiger and a wolf. Both of these species were said to be quite large compared to the tigers and wolves that we see today. So this, the evolution of such mammals took a pretty significant effect on the remaining theropods, such as that Archaeopteryx that I just mentioned. Basically, with these mammals being predators for most of the earth at the time, they provided a lot of competition for the remaining theropods. They were basically dominating the prey at the time. So the Archaeopteryx and other birds that were around basically were forced to get smaller and look at different food sources for food than they would have previously. This is one of the reasons why today we see that many birds actually are omnivores, meaning that they eat meat and vegetation. But I would say mainly birds today actually are herbivores. So to continue here, there is a great deal of evidence to suggest that birds actually are related to theropods. One of the pieces of evidence is basically the anatomical evidence that is available. Brian Hall produced a scientific paper that basically did a thorough dissection of the Tyrannosaurus rex and analyzed its anatomy, comparing it to birds today. And he found two striking similarities between these species, one of them being the fused clavicle, also known as the wishbone, that we see on the left here, and one of them being the fused metacarpals that we see on the right here. Both of these features are prominent among birds today, and were also in theropods. Another significant piece of evidence is basically the similarities in collagen fibers between theropods and birds today. There was a study that was led by Mary Higby Schweitzer, where basically she analyzed the collagen fibers of theropods and birds, and she actually produced this image that we see here. The letter D here is the Tyrannosaurus rex collagen fibers, and the letter E is going to be emu collagen fibers. You can see a pretty similar